So this is another very interesting attack, okay, format string. So format string, so you've been using format string, okay, so, but many of you probably didn't actually think about that this printf function is a very special function, right? So I don't know whether anybody paid attention why printf is so special, different from the function that you implement. So what are the special things about the printf?
Is it a system call?
It's not a system call. It's a function. It's a library. Yeah, eventually it's going to call some system call, but it's a library, right? Function call. So, but it's a special. There's one property which is uniquely separated from many of the functions we write. Okay, what is that? Yes. So the unique thing is the printf you can provide with any number of arguments. Most of the functions you write, you can, right? If you define a function, you have a two variable, a 2 argument. If you're trying to call this function with 3 arguments or with 1 argument, the compiler is going to tell you something is wrong, right? So, but printf is fine. You can provide. So in this example, you can say I'm printf with 1 argument, with 2 arguments, 3 arguments, 4 arguments. You can provide many arguments, and printf is going to work. So. And you may think maybe inside of the header file, they have defined the printf with 1 argument, 2 argument, 3 argument, right? You may think about maybe there's a definition like that, yeah. But the good thing is there's no, it's not, okay. So, and there's a way to define a function with variable length of the argument, okay. So that's what we're going to talk about. So actually, the printf is defined like this. Okay. And this 3 dot dot is not because I'm lazy. Okay, it is a 3 dot dot in there. Okay, so when you define this, you do put 3 dot dot there. Okay. So this is a code. I'm just defining my own function. Okay, I call it my print. Okay, this is different from printf. And my print, I will have a variable length of argument. So you do put dot dot. Okay, you do need to provide the first argument. Okay, the first argument is required. Okay, and then after that, you put dot dot. Okay, I think you can also provide the second, third one, and then put dot 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 there. Yeah. So, but you need to have at least one. Okay. So now inside of this, okay, and you can see I will do this. Just ignore this. Okay, and I can call my function with 1, 2, 3.5, 2, 3, 4.5, 4. I can invoke my function in that way. Okay. Now the question is, how does this function work? If you define a variable length of the function, how did it work? We know if we define a function foo, right? We have int a, int b, and we know that in the stack, a is going to be pushed in here, b is going to be pushed in here, right? So and then a and b is going to be referenced by the EBP plus 8 plus 12, right? That's how that works, EBP. So if you have this fixed length of argument, that's how it works. Now what if you have this one? Now how do you reference the second argument, third argument? Because when you do this, when you call this one, the second argument will be pushed. If this is the one, okay, 1, 2. So this is RA, okay. 1, 2, and 3.5. Okay, it's going to be pushed in here when you make this call. Okay, and in this case, then 5 number will be pushed inside. The question is, how do I reference those numbers? When I define this, I only define 1 number. When the compiler compiles this, it only have 1 argument. This argument it will know EBP plus 8. That one you can know. But then there's a lot of dot in there. Compiler doesn't even know whether you're going to have anything in there. Right? So how does compiler knows? Compiler doesn't know. Okay? So compiler is just going to ignore those dot. Okay? So now it's your responsibility and to actually go find where the second one is, the third one is, fourth one is. Okay? It's your programmer's responsibility. not compiler. Compiler is only going to push the n-arg inside. This n-arg, the first argument, usually is to use to specify how many arguments you are going to have. Okay, so in this case, I put 1 in there. Okay, so that means I have 1 argument. Yeah. So I have 2 arguments, I think. No, I think this example is wrong. Okay, yeah. So, but the first argument usually is used, but it's not required. It's up to you. Okay, it's up to you to decide what to do with first argument. In the format string, in the printf, the first argument is a print string, is a format string. Okay, so that is format string. So printf needs to have at least 1 argument. That argument needs to be the format string. Okay, so that format string actually decide how many arguments you have after that. Right? Remember, the inside the format string you have %d, percentage x, right? And printf is going to count how many percentage sign you have inside, and then printf knows how many arguments you're going to have. Okay, so that's how the printf works, and that's how any actually the function that has a variable length of the argument work. They have to look at that by themselves. Okay, there are standard way to do that. Okay, so they do provide a lot of macro. Okay, so when you write this function, the first things you do, you have to define a variable like this. And when you start, you have to call this va start, and those are macro. Okay, those are not function call. Those are macro. Basically, they replace this with a bunch of code. Okay, so what they do is they initialize this argument. They initialize this AP. So this AP, it's a pointer. Okay, and point to the first argument. So AP basically point to the first argument. Okay. Now, every time you process one, you have to advance the pointer to the next one, and you have to do that by yourself. Okay. So this var basically advance the pointer by certain offset. That offset is decided by the type. Okay, so in this case, it's advanced AP by an integer, size of integer, which is 4 bytes. Okay, in this case, the pointer is going to be advanced the size of the double. I don't know how many bytes they have, maybe 8. So you got to do that inside your own program, and to do that. Okay, so you need to know what the second argument is, what type of second argument. Okay. Usually, when we write this one, all the arguments they have the same type. Okay, they have the same type. And if you have very different type, it's going to be very, very difficult to write. Okay, and the format string, and they use the percentage type of percentage to decide what type you have. So percentage x, so percentage d, percentage f. They use those percentage sign. And to know for that the corresponding argument, how many bytes. Okay, so inside of implementation of printf, they will advance the pointer by that. Okay, so in this case, the AP, so first one is going to be the n-arg. N-arg is going to be here. Now, so n-arg, in this case, I put 1, and then 2, 3, 5. Okay, so basically it's going to be the print out this, not print out, it's going to first going to do this, and then when you actually call the var, it's going to advance to here, and then var again is going to advance to here. Okay, so that's how you actually find the second one, the third one. Okay, you are not using EBP plus something. Compiler doesn't know how many you're going to have. So compiler is not going to actually convert those into the EBP plus something. So it's your job to really to go through that list. Okay, so that's how that printf works. Okay. So printf, if you look at the printf, that's exactly what. So this is actually implementation of printf. So it started with the va start and end with van. That set the first argument to this format. And inside of that is called VF printf. And basically, VF printf is going to parse that format string. It's going to actually parse that one by one. Okay, so this is %s, okay, %d, assuming this is what the format string looks like. And this VF print is going to actually just parse this string, and it says %s. Okay, it knows I need to print out. Okay, I will replace. I will not print out the %s. I will replace the whatever's in here with the here, what the stack looks like. A stack. Format is here. The address of format is here. The arc of initial point to here. When they see the %s, and it's going to fetch from here, the arc is going to point to here now. This is supposed to be second argument, right? When you call fprint, this is going to be second argument, and whatever you put in here, okay. So whatever this argument, let's say this is a name message, MSG. So this is supposed to be a pointer. When they say the %s, it's going to say I'm going to print out what is pointed by that variable. Okay. So this is going to treat this as address to a string. And it's going to actually print out the string here. This string is going to be printed out in here. And after that, this will advance to the next one. Okay. Then it's going to continue scan, okay, until you see the %d. Okay. And then it's going to say, okay, %d, you want to print out an integer. So I'm going to treat this part as an integer. I'm just going to print it out. Okay, so this value will be directly printed out here. So at the end, it's going to print out this is a message, and this followed by this number. Okay, so that's how the format string works. Okay, the problem is when the number of the argument and the number of percentage sign do not match, that's going to create a problem. Okay, that's what we're going to talk about, how we can take advantage of that mismatch and to achieve the damage. Let's just work on this. Okay, so let's see how this thing works. Okay, this printf. So we have printf. Okay, so let's see how this printf actually works. So now when we call the printf, okay, when you call the printf, you're going to create a stack, right? The stack. So, and this part is going to be stacked for the printf. So let me leave 3 space, 1, 2, 3 here. And then this is going to be return address, right? This old EBP, right? And then that's going to be local variable for printf. We don't know what kind of local variable they have. But this is a standard. When you make a call, so what is this element? This is going to be the string to this string, right? This is going to point to the string. Let's see the string somewhere. Okay, so point to that string. So this is going to be address to that string. And this is format string. Okay, that's the format string. So what is this element? ID. What is we can only put a value 100, right? Because ID equal to 100, so you don't push a variable, you push a value. And then name is also a string to point to Bob Smith. Okay, so we also have this address. Okay. Now we are inside the printf, and let's see how the printf works. So if you notice, we have a mismatching number of the percentage sign and the number of parameter, right? So and now typically compiler will not complain. Typically, okay. And this day is a more advanced compiler, and they do have an option, and they will detect this mismatch. Okay. So and that's only if the format string is known. In this case, I put a constant string in there. In the real world, you may have a variable here. In that case, even compiler cannot tell, because the string value is not even known beforehand. But in this case, your compiler will definitely tell that something is mismatching. That's a more advanced compiler. Typically, compiler, they have no idea. They will not look into the string. Okay, so everything is going to compile. To the compiler, it's just you are calling the printf function with 3 arguments, which is allowed. Printf has a variable length of argument. Okay, so now inside of inside of printf. Now let's look at how the printf works. Right? What the printf is going to do is the printf is going to actually parse this string. Okay, the printf is going to parse the string from the beginning of the string. Whenever you see a character, and what does it do? When you see the ID column, what does it do? You should know what the printf does, right? What does printf do? Just print it out, right? So, hey, this is not a tricky question. So it says I, okay? It says, okay, I'm going to print out I. That's my job. When I see D, I'm going to print out D. And now, when you see the percent D, this is where it will not print out percent D. Okay, this is where the printf knows, okay, you want me to print out something. Okay, so this is a command to, okay, so this is a format. Okay, so and printf knows you want me to print out integer because D means integer. Okay, and using the decimal and the format to print it out. So where do I get this integer? Okay, so remember for this kind of function, the function with variable length of the argument, it will maintain a pointer. Inside of that, it's going to print a pointer. Initially, it's going to start with this one. That's the first argument. Okay, and now it says %d, and it knows I need to look at the next argument. Okay, so the pointer will advance here. Now the internal the pointer, okay, it's going to point to here, and it's going to fetch whatever the number here. It says integer, so fetch 4 bytes of integer from that place, and print it out. Okay, so that's how this 100 got printed out in here. Okay, so and then, of course, it's going to advance this. After this is used, the pointer is going to advance. Next time it's going to be different. Now, after that, it's going to keep scanning this. Okay, and now to get the name. So the name is going to print out. So the comma is going to print out here. Column. Now, when you see the percentage S, now percentage S is different from percentage D. Percentage S is, I'm going to treat these things. Oh, I should not erase that. Okay, so percentage S means fetch that as an address. Treat whatever is pointed by this pointer as an address. Print out what is pointed by that. Okay, different from %d. %d means I just want to print out the value. Whatever the value is currently stored on the stack. This ones, I'm going to treat you as an address. I will not print out you. I will print out whatever is in that address. Okay, so it's going to actually use, and it's going to look at what the pointer points to. It's going to say, okay, I got something here. Okay, and I'm going to actually go to that address, whatever this says. Okay, and I'm going to start to print out the string. Okay, pointed by in that address. So, and that's where the Bob Smith is going to print out. So remember, it has to have the ended by 0. Okay, if this one not ended by 0, it's going to keep printing. Okay, whatever is in there until it sees 0, and then it stops. Okay, so now after that, it's going to do the age. Okay, next one is going to be age, and then now you see the %d again. Now what's going to happen? I don't have a third argument. I don't have a third argument. But inside of code, they don't care. They don't even know you actually reached the limit now. Okay, they will just keep actually advance the pointer. Printf is going to keep advance the pointer. Printf doesn't know I have reached the limit. Okay, so it's just going to go continue whatever is out there. Whatever is out there, it will be printed out. Okay, if this is 90 is here, okay, and then 90 is going to be printed out here. So although you only provide 2 variables here, but this will be executed correctly, not correctly, will be executed, and something on this one will be printed out, although that's not your intention, but something is going to print it out. So inside of printf, they don't even know how many parameters you're going to have. They don't know. And what they know is they have a pointer, okay? And they're going to actually go one by one, okay? And if you need more, and they're going to advance pointer. Okay, yes?
So where would, you did declare age to be 25, so where would that be in that stack?
The age, so you can see age is never used. So this variable is never used. I didn't put in here. So this local variable basically is not used. So the program actually forget about should we put age in here. Right? Should put in age when you invoke this, but the program forgot. The age is somewhere in the main functions. Okay? If you draw the frame, the age is somewhere in here, in the main's local variable area. It is there. Yeah, but not exactly there. You may be lucky. You may be lucky. That's exactly there. That could be the case. Okay? But most likely you probably is not going to be that lucky. Okay? Yeah. So basically it's actually, it will advance into the stack frame of the main function and then print out something inside the main function. Okay? So that's how the printf actually works. Okay? So remember this pointer starting with a format string, then keep advancing based on how many percentage sign you have. Okay? So is this clear? Yes.
So I just want to explore this a little more. If you had a %d, but you just put in name, would it print out like the address?
Yeah. Yes. If in here instead of using %s, I have %d, then this address will be printed out. Okay. So yes, it will print out, but only this address, not actually that string, not a string. %s means don't print out the address. Print out what is in that address. Okay, that's %s. Okay. So is it clear? Okay, if this is clear, then let's look at it. This is definitely a problem in the printf. Okay, you can see there's no boundary checking. The printf will just keep advancing to the next, although this is not even belonging to the printf stack frame, but it will continue. Now the question is, what can go wrong? Assuming now this program is running with a root privilege. Okay, now it takes input from outside. Okay, let's see. Let's see this program. So just this program. In this program, I have a main function. Okay, and then I'm going to just do the scanf and to get input and to put this inside of this variable. Okay, and then I'm just print out this. I go. Okay, the typical way to print out this is going to be printf %s and then user input. That's what you're supposed to provide. Okay, you provide a format string, then you print out a string, but this developer is kind of lazy, so it just say I just want to print out this, and so basically you only have one parameter, right? Remember, printf is going to look at this parameter, and if this is just a string, the printf will print out a string. Okay, nothing's wrong. Okay, if this whole thing is a string, printf will print out. Okay, and doing this and doing that is equivalent, unless you have a percentage sign inside here. Then that's going to be different. So that's what we're going to explore. You have full control of the input. Okay, so here let's not worry about the buffer flow. Okay, the way how I wrote this program is wrong way to write a program. That's a buffer overflow problem here, right? If you see that, right? Because the input can be longer than 100. Okay, so I shouldn't use this. What should I use? If I want to get an input, What should be the right function I should use? So I don't have buffer overflow. Here I will definitely have a buffer overflow because the user input may be longer. Yeah, fgets. Okay, so remember a lot of these the function that we have, and they have the safe version. Yeah, so string for this function we have a string ncpy, right? You specify the length. Okay, so a number of them they have the safe version. The scanf they have a safe version. Yeah, we didn't talk about that, but the safe version is fgets. And so fgets basically this is the buffer, okay? This is the buffer, and this is the length. You specify length. So in here I'm going to specify 100, okay? And then you have to provide the input device. We use std_in. That means I'm going to just get from the keyboard, okay? And this could be a file descriptor, any file descriptor. fgets can be read from a file, but you said I just want to read from the keyboard, the standard input. Okay, those are the reserved word. std_in is actually reserved. So you should use that. I should change that scanf to fgets. Okay. Now we don't have buffer overflow. Okay, and so this will be this. So this actually buffers this user input. It's going to be actually the content of this is going to be provided by user. User can put whatever they want. Okay? And now this setuid program doesn't need to be setuid. This could be a server program. Okay? And they are trying to print out this input provided by the user. Now we call the printf. The printf, remember the printf is going to be this is going to point to here, point to user input. Okay, that's the argument provided to the printf. Okay, so printf is going to actually scan, starting from there's a pointer, internal pointer inside the printf. It's going to starting from the beginning of the user input, and it's to scan this. If they see a character, just print it out. So if everything in here, if what you provide is characters, everything in this buffer will be printed out. Okay, and that's the intended goal. Okay, now if you have a percentage s inside, and this will advance. No, sorry, pointer is not point there. Point here. Okay, it's always point to the format string, and then this will advance. Okay. So definitely something is going wrong, right? So now, so if you can provide percentage sign inside of the input, okay. Now what I want to think about, what can you do? Yes, you will be able to print out something on the stack, but given that you have a full control of this input, given that you can put any number of percentage XYZ inside, what can you do? Okay, print out everything on the stack. That's good. So if you have some secret value stored on the stack, that can be printed out. That's good. Okay, what else? What else can you do? So imagine this is a server program, okay, and this could be a server program, not necessarily setuid program. You take the user, it's running on the remote server, okay, take whatever the input from the user, and print it out and to the terminal, okay, or print it out to the file. It doesn't need to be printed out on format string. Can be used in fprint, okay, fprintf, okay, and then you can print out to the file, okay, and you have the same format issue, okay. Yes.
If it is writing to a file, which we know where it is, we can put executable code in that and we can try to execute.
Usually those files are not executable. Log file, yeah. Yeah, log file, yeah. So they're not going to actually write user input to an executable file. I don't think any program is going to do that, okay? Yeah. So.
You can essentially print out private information for people to use that server.
Okay, private information, that definitely covered, okay? So anybody else? Now, before we talk about this, let me just show you several things that the parameter. %d, we know that, print out decimal, %u, print out unsigned decimal, %x, hexadecimal, %s, the string, %n, that's interesting, that's something we will talk about. Okay, %n, probably nobody has used this before. Okay, at least when I learned this, I never used %n before. Okay, we'll talk about that. So that is very useful. We will talk about that. But before that, let's see first, can you crush the program? So this is a server program. It takes your format string. There's no buffer overflow. Okay, it just wants to print out your whatever you provided, and the program doesn't actually definitely going to exceed the scope. Question: can you crush the program?
Yes.
Okay, how?
Accessing space that is not for the code.
Okay, so let's look at this. So you're right. Okay. So let's see inside of printf, right? So this is actually the format string. Okay, the pointer is going to start with here. Okay, now that string actually, this string is actually stored somewhere else. Okay, so let's, in our case, the string is stored also on the stack. Okay, not in the buffer. Now, what do you provide in that string that can crush the program? Okay, so
Some percentages and some invalid address.
so what do you put? Tell me the string.
Percentages
%s,
and pass an invalid address.
address here,
No, comma and
comma. Okay, you can only provide the performance string. Okay, you have no way to change the program. The program basically just print out whatever the input you provide. Okay, you have only control of the input. You have no control of the code. So now anything you need to do has to be done through this format string. Let's see we put a bunch of %s. What's going to happen? First %s is going to go to here, right? It's going to take whatever is in here, right, as address, and then print it out, right? So can this crush the program? It might, right? Because what if this is 0? Right? If it's 0, you want to print out something in address 0. Remember, address 0 is a protect area. It's owned by the OS. Okay, you are not even allowed to enter that area. That area does exist. Okay, it's not that 0 doesn't exist. It exists. It just you're off limit to you. Okay, so if it's 0 or if some other value, if it's 10, 100, and we mentioned right in the buffer flow attack, if you just put a random address, there are certain conditions. Once this happens to be your address, then something is going to print out. Second, this is the OS space. Now you cannot enter. Third, there's no such memory, right? It's a virtual space address. There's no actual physical memory mapped to that virtual address. Okay, right? So it cannot print out. Question?
You said it can print out stuff as a string, yeah?
Yeah, it's going to no, it's not going to just string. It's going to treat this as address. When you see the %s, it's going to go to whatever in that address, and treat everything in there as a string, start and print it out. It may not be a string, but as long as it doesn't see 0, it will keep printing until it sees 0.
Yeah, that's what I was going to say, that you can keep printing forever.
Yeah, somewhere you will see 0. Okay, somewhere you will see 0. Yeah, so, but it's unlikely that you don't have 0 in the memory. Yeah, so even if this memory does belong to you, okay, it will keep printing. You from the terminal, you will be able to see some of the non-printable character, right? Some of this the gibberish type of things, right? Because those are value, and those they don't have a printable, and you make some bells, because some of the character those are the ring a bell type of the character, and you will see also this kind of thing, but it will print out things unless this address is invalid, then the program crash. So all you need to do is to put a bunch of %s. One may not work, go to the next one, go to the next one. If you provide enough, your program will eventually crash. Okay, so that's easy, right? You can try that. Just provide this. Yeah, we do have a lab for this, but we're not going to assign to you. But if you're interested, you can work on that. Okay. What is more interesting is the next and the next few. So you have talked about, you pretty much answered the first question, how to print out some secret value stored on the stack. Okay, so I'm going to ask you to continue, how do I construct the format string to do that? So here's my format string. This is the pointer, the first pointer, okay? And it's going to actually move, okay? Every percentage sign is going to move. So I want you to tell me, what do you put in the format string? So it can print out, let's see, here's a value, secret. And you are here, and you want to print out that secret. So how do you do that?
It's going to be that address minus.
So let's see. Let's put a number. This is 20 bytes. The distance from this and this is 20 bytes. What do you do?
String pointer is 4 bytes.
Yeah, 4 bytes. Okay.
So you
How do you construct your format string? Percent D. How many do we put? We put 5. Very good. 1, 2, 3, 4, 5. You put 5% D. Every percent D is going to advance the pointer to the next, until you see this one. Your secret is printed out. Okay, and so that's what you want. Oh, of course, everything in between got printed out. Okay, so, and what is this secret is not here? It's actually a string. And then what you need to do is to change the last one into %s, right? And so if this is stored in some other place. Okay, so now I'm going to ask you the next more challenging question. Now, this is not on the stack. Okay, so, and you don't even have a pointer on the stack. So here, this memory is not on the stack, but you got edges here, right? That's how you can print, right? If the edges of the memory is on the stack, I can print. Or if this memory is right on the stack, I can print. What if I know this is somewhere here? The edge is 0x, A, B, B, C, C, D, D. That's edges. I know there's a secret inside. Okay, through GDB, I know there's a secret. Password, for example. Okay, super user's password stored in there. They're not supposed to do that. Okay, assuming they did that, I know the edges. How can I use in printf? How can I use the vulnerability of format string to print out that? Okay, so how? Yeah. So here, how do I? You have to tell me how do I construct that format string? What kind of format string should I construct so I can print out here? We talked about this case. The value, the secret is right in here, right? We know how to do that. We also know if the secret is here, but the address is on here, I can do that as well. Okay, all I need to change the %d to %s at the end. Okay, assuming this is a string. Okay, now I'm talking about a case where nothing like that happened. No address on the stack. Okay, nobody's actually point to here, and this definitely is not on the stack. Now I still want to print it out. How can you do that? You can provide, of course, the format string. The format string is provided by you. You can put whatever you want in the format string. Okay, so and this format string pointer here. Your job is to fill in this buffer so you can print out a secret of the stack without that address on the stack. Right now the address is not on the stack. To do that, the address has to be on the stack. Okay? The only way to really print out that using the format string is you got to get the address on the stack. How do we get the address on the stack? Okay? How do we get? Use a pointer. Okay, no.
As part of that format string.
Very good. So this, you have a control of this, right? You have this. They allow you to put this these things onto the stack, okay? Because this format string happen to be on the stack in this case. So what if I just put this 0xAABBCC in there, okay? So what if I just put 0x? Okay, remember this 0xAABBCCDD, okay? 4 bytes, okay? These are not capital AABB, okay? And you have to you cannot you cannot actually type this, right? Because when you type A, that's capital A. Okay. In order to fit that, you can save your input, your binary. This is binary into a file. Okay. And then you use redirect. So if this program is called vulnerable, okay, and you will redirect the input file. So you have to prepare like the bat file will prepare, okay. But in the bat file case, the program does read from the file, right? In this case, we are using this. So inside of this, they expect to from the getS, right? From the standard input. By doing this, you are telling them my file is standard input. Just read from my file. Okay. So that's how you can actually input the binary. You can type binary. Okay. Binary are not typable. Okay, but this is how you can get this 4 number inside. So you got this address. Let me just write it in the 4 bytes case, AABBCCDD. Now you can do the same thing. Figure out the distance. Maybe the distance now becomes 60 bytes. Now, of course, you need to know the offset between here and here. You can use GDB to figure it out. Now 60 bytes, that means I need to put 15 of %D, right? %D, and eventually I got to put a %S, right? So I got there's 14% D, right? And I don't know, maybe 15. You have to check. Usually boundary things is confusing, okay? And the last one is %S, okay? So don't quote my word for that. Could be 15% D and 1% S. But at the end, it's going to %S, okay? So you got to actually advance, okay? So you got to advance this. So if you advance 1% D and let you go up 4 bytes above, okay? So it is 14, okay? So eventually, and you're going to actually go to here, and then when you advance to here, it's going to be %S. So, yes?
How did you say defines the distance in bytes between where you are?
So here, so remember this is the buffer in the main function. And you can debug that program using GDB, and you find the distance. As long as randomization turn off. Yeah, even if it turn on, I think the offset is same. They don't randomize the offset. Yeah, so I don't think the randomization is going to help much. Yeah, so you can find out the distance between here, and you can, yeah. So now you know how to do this, right? Now let's go to more challenging things, okay? How to modify the data stored on the stack. Now we have crashed the program, we read something. Now I want you to modify the something on the stack. So here, the buffer here, okay? And your pointers here, initial point, format string pointers here, okay? So that now there's one place. There's one place here on the stack, okay? And this value right now is 0. Okay, you want to change it to non-zero, because inside the program is going to check if this equal to 0. Okay, no privilege. Else, have a privilege. So this is a very important flag. Now, if you cannot turn this into 0, you're not going to enjoy the benefit. But now with a format string, your goal is, how can I turn that number flag into non-zero? I just need to turn it non-zero. I don't care what value I want to put it. How do you do that? Okay, so that's where you got to introduce the percentage n. Now, if you put something percentage n, so let me give you an example, percentage n. Okay, I'm going back to that slide. So percentage n, if you have example, let's see, hello, percentage n. Okay, so your printf, and here you need to provide a pointer. Okay, and let's see, I have integer. I already have an integer and provide the address of that integer. What does it do? It is going to actually, when it sees the percentage n, it's going to count how many characters has already been printed out. So it's going to see 1, 2, 3, 4, 5, 6. It maintains a counter. Every character is printed out, it maintains a counter. Okay, so right now the counter is 6. Okay, so 5 plus a space. And it's going to actually store 6 inside here, the value. So after that, I is equal to 6 now. So that's what it does. Okay, and this not many people use that in the past. Maybe when we don't have a laser printer, right? When you have this line printer, right? You have to print it character by character, line by line, and this is going to be very helpful for them to know how many characters I already printed out, so they can do the formatting. That was way old, okay, maybe 80s. People probably use that. But now I don't think anybody uses percentage n. Okay, but it's there, still in there. If you have a percentage n, what makes it different is this allows you to modify a variable, right? Everything else is just print out things. This allows you to print out whatever's, okay? Now can you use that to save something in here? Can you do that? So let's see the distance is 20. So what should we put in here? The string. First we need to advance the pointer, right? We need to add, right now the pointer is here. It's pointing to the format string. Now we're going to advance that. We're going to percent d. We're going to advance 4 times. Okay. Last one. Okay. Now everything, of course, everything here is going to be printed out. Now if I put the percentage n in here, okay. So if I put a percentage n in here, what's going to happen? The value is going to be right in here. Are you sure? The program will crash. The program will crash. No, it's not. It's because percent n is going to treat this as an address. It's going to treat this as address, and then save whatever, how many characters. For example, at this point we are already printing out 100 characters. It's going to save this 100 to that address. That's where you're going to have a problem. Okay. So, and you cannot use this way to save to here, because right now this is 0, that address is 0, and it will crash the program. And you have to use some different tricks. How do we improve on this? Remember what we did? As we know the address, we can find out the address. Right? What did we do in the previous case? How do we print out something from a particular address? We just put this address in here, okay? So this address, let's say this is the address, okay? So 0xAABBCCCD. Put in there. Then do the same thing. Advance. Once you get here, instead of percentage s, you do the percentage n, right? Because this one point to this place. Okay, that's how you override this. Okay, so this doesn't need to be on the stack. Okay, and this memory can be any place as long as you know the address, and you can use same tricks.
Professor, isn't that program going to crash because it's going to say C0 before it goes to the address?
No, you percent d, right? When we get over this, when we get here, it's going to, you put a %d. %d means print out the value. So 0 will be printed out. Okay? So you can actually, you will go over this, but 0 will be printed out. Okay? So once you reach here, then you do the %n. Okay? Any questions? So the technique is similar to the previous one. Okay? So now if you are clear, okay, I want you to do more challenging things. Okay? So remember the value that we provide, we didn't control the value, right? Whatever you print out, 100, 200, we don't care. Now, the system also only look for that particular value. You got to set that field to this number. Okay? So let's see how we can do this. So now we can put this off the stack. Okay? We know it doesn't matter as long as we know the address 0xAABBCCDD. Okay? Now format string is going to be here. I know we're going to put the 0x. That one is the same, 0xAABBCCDD in here. Okay, so, and now you're going to advance. Okay, so this one definitely is going to point to here, right? Now I want to save a value. Okay, save a particular value, not whatever the value. So remember, if you just do the %d, our techniques, after that we have just have a %d, right? All the way until we get a %n, right? That's our string. At the beginning is the address, but then after that we have %d. Okay, so now initially the pointer point to here, and it's going to print out this number, okay? Because that's the beginning of the format string. Then AABB is going to print out. Definitely you're not going to see AABBCC. You're going to see this. This is the ASCII value of whatever the character. I don't know what the character is. Maybe it's something not printable. But you're going to see something printed out here. And then %d is going to move this, right? Another %d is going to move this. Eventually, we're going to get here, right? That's where we are supposed to have a %n, right? So everything here is going to be %d, until we hit this address. We put %n. Now, whatever we print out in the middle, and the printf is going to count that, right? And this maybe is 200. So 200 is going to be put in here. Now, I want you to be able to control that value, not just depending on how much is printed out. Okay, I want you to be able to control. So let's first see how can we control the value. Then the second is how can we make sure the value is like that. Okay, first, what if this right now the value is 200? If I just keep doing the %d, and I will get 200. I don't like 200. I want 300. How about that? How can I do 300 instead of 200? Remember, it's based on.
You can just add arbitrary characters between the last %d and %n. Just A and B.
Very good. So add additional thing, right? So without advancing the pointer, okay? So you have a %d, and then that's going to be last %d, and add a lot of this character, okay? You cannot put another %, because you put one more %, it's going to advance pointer, okay? But if you just put A, B, B, C, C, whatever the character, it will print out. And you just put 100 of them, because up to here you got already 200, right? Now you put 100, right? And now you get 300, right? That's how it works. But unfortunately, it won't work for this case, because the buffer size is 100. Remember, our buffer size is 100, and there's no buffer flow. If you added 100 of them, you don't have enough space. The whole size is 100. But this idea, okay? I want you to improve on that idea. So without putting 100 of them,
Where does it store that value? It counts.
it's going to be here. whatever you put in here, the string, whatever you type, is stored in this buffer.
You say printf counts the number of characters printed.
Yeah.
So where does it maintain that?
Maybe it's in the local variable somewhere. I don't think you can touch that. Yeah, in a local variable inside of it could be on the heap. I don't know. Yeah. So how do you print out more, but without putting more character? So %d. What if %d is only two digits, but you want to print out 10 digits? Can you do that? Did you use %30d like that? Used before, right? You can put a width and in front of %d. That means I want you to print out this number using 30 space. Okay, if you don't have that enough digit, put a space. Okay, so that's actually width as the modifier, and you can use that. So in this case, I don't even need to use this. I just need to do a bunch of %d, and then maybe at the end I will put some number, and %k. That's this number I'm going to calculate k. Let's say this could be 100. Okay. Then I'm going to actually make it larger. I can control this value. Okay. So and then at the end it's going to %n. Right? We can do that. So that's very good. That's very good. So we can. And now, in order to do that, it's going to be a long story because, and you're going to put a large long number. Let me just ask you one more thing before we get there. What if I want to print out 100? So I already print out 200, right? Now, in order to print out 300, we found a way, right? We increase the size. What if I want to make that value to be 100? I want to be less than what you already have. What do you do? No, it's not possible. So good try. Good try. Okay, so that was quite interesting. Okay, so that one is we have to talk about some other things. Okay, so this is doable. Okay, this is doable, and in the percentage n, that's one thing I did not tell you about. Percentage n allows you to write to 4 bytes. Okay, 4 bytes. So %n basically treat that address as 4 bytes and write this entire 4 bytes into that. Okay, 4 bytes. And then the percentage %hn, so overwrite 2 bytes. Basically it says treat that number as a short number. Okay, write this value to that short number, 2 bytes. And then that's actually percentage hn, so overwrite 1 byte. So there are actually a number of these things. If you specify percentage hn, then you tell the printf to treat that as a 1 character, one byte number, and save this to that 1 byte. Okay? So if this value is larger than 1 byte, what's going to happen? If this is 300, save to 1 byte, what's going to happen? So if my number is 300, I save to 1 byte, what's going to happen? You may not crash the program. It's going to be the 300 minus 256, right? It's basically modular. Yes, I think what you described, Sam. Yeah. So it's going to be some value, okay, minus 256 because that's overflow, okay. But they will actually remove that overflow part, 256 removed, and only the last 8 bytes is saved. Okay, whatever is actually above 8 bytes is thrown away. That's the technique you can use by saving to this a small number. I won't go too much into this, but I just give you an idea. Okay, so to do that, you have to write it 1 byte by 1 byte. You're going to treat this number as 4 bytes. Okay, and you're going to fill in these 4 bytes one at a time. So you're going to have to basically do this kind of thing 4 times. Every time you save to 1, okay, and then you do another one, okay. So you can do this all entire one format string. Okay, that's the tricks to do 1 byte at a time. I don't want to get into this because involve too much, and I don't think you need to know all this detail unless you want to do the lab. Okay, but what I want you to know is you can write an arbitrary number. Okay, that's why I put in here. How do I write an arbitrary number into the space? Okay, what the idea to do that is to split them into 4. Write 23 into the first address. Write A4 into second one, and 02 into third one, and BC into the last one. Okay, so and remember the count is increasing, right? It count increasing, but it doesn't matter because I only have 8 bytes, right? After I finish at 23, if I need to write to A4, I will just add a few more characters. I'll get A4. But from A4 to 02, I have to rely on the overflow. And because my count is going to increase A4, A5, and then to 0, 01, 02. Okay? So that's how you can do that. So the format string looks like just a very benign vulnerability, but you can pretty much do this. Okay? This clear? So this part I didn't dive into this, but you need to understand the idea. Okay? So the idea is you can write any value into any memory space if there's format string. Okay? Now, this is what I want you to discuss. And I'm going to give you 10 minutes to do that. Okay? So now you learn everything here. I want you to use this to jump to your injector shellcode. Kind of buffer overflow. So we are not just interested in modify a secret value, print out secret value. I want to inject code into it. I want to run my code. And a format string vulnerability allows you to do that. Okay, I want you to spend 10 minutes to discuss, to tell me how you can do that. Okay, and you don't need to tell me exactly how many %D to do that, but I want you to tell me the ideas. The goal is that I want to inject, I have a shellcode which I can inject. Injecting shellcode is not difficult. I have this user input, right? You ask me to buy the user input. I'm going to just use part of this as shellcode. This part is going to be shellcode, and this part is going to be a format string. Okay? The goal is how do I construct this format string so when the printf returns, it returns to my shellcode. I want that to happen. We don't have a buffer overflow. We know if we have buffer overflow, we can do something like there's no buffer overflow, okay? But format string, there's an overflow, right? It's cross boundary. I want you to tell me how you can do that. Okay, think about that. Basically, you have to combine what you just learned, right? So we learned about how do we write to a particular address with a particular value. Now, that's what you need to use. Okay, so we learned, so given a particular address, any particular address, and we know how to use format string to modify this address value and to point to where we want. Now, in order to solve this problem, what is your target? That's what you want. Okay, and what is the value that you want to write to? And that's what you need to find out. If you can find these two, and you can solve that. Okay, so in order to jump to shellcode, how do we jump? Right? Return address is in the buffer flow, right? Return address is that how we can enable us to jump to somewhere. So if the area is a return address, right now we are in the printf. There's a return address here, right? Because we don't have overflow, so we cannot overwrite this. But format string allow me to save any value to any address. So I'm going to pick the address here. So this is going to be my target. I want to modify the value of this with this value. Okay, and this is the value x. That's starting point of my shellcode. So my goal is to save this into this field. Now, if I can successfully doing that, x now saves in here. right? Now you actually return to the shellcode, and you run my code. Okay, so you can see for the format string, right? It looks like a very, very benign actually mistake. It just sounds simply because the program is a little bit lazy, but because of the way how the printf is designed, okay, and you can actually do this kind of attack. You can eventually even inject your code and completely take over and the server or set UID program. Okay, but to be able to do that is a little bit tricky. Okay, so especially the byte per bytes and that kind of change. Once you know how to do that, it's doable, but it's a little bit actually complicated. Okay, but theoretically that's doable. Okay, in the lab we don't ask you to do this kind of thing. We just ask you to be able to put a value into a variable. Okay, so the lab is much more simplified than what I just talked about. Okay, so is this clear? So this end this our discussion on the